Good evening everyone, and welcome to video 6 in the HQ Lab series. Today we are going to be configuring the interfaces on the Firepower threat defense devices via the Firepower Management Center. But before that, I just want to touch on the reason why I haven't done a video in a few days, and this is due to my Eve lab running a bit slow. I think we saw that in the last video. So after a bit of troubleshooting, managed to find out what it was, and this was down to a couple of reasons. So the main one was that I'd let the Intel Turbo Boost look after my overclocking of my CPU. What I found was that when looking at Task Manager, for instance, and keeping an eye on the processor speed and utilization, when I was starting devices up in Eve NG, and obviously that was causing a spike in CPU within Eve itself, I wasn't seeing that in the Task Manager. So what I did then is I manually configured an overclock. Pull this up right here. Yeah, so I manually configured an overclock on my processor to 4.2 gig, and I statically set the voltage as well, and that seemed to help out a lot with the speed and general responsiveness of the devices in EVE-NG, especially the Firepower devices, which are quite resource intensive. That wasn't the only thing. So after a bit of digging, I found that also I was allocating all of my CPUs, my available CPUs, to the EVE-NG VM. So I have an 18 core processor with hyperthreading, so 36 virtual cores available, and I was allocating all 36 to EVE-NG. That's not best practice, so I've tuned that down now to 32. And I now currently have 108 gig of RAM to it, and then a 2 terabyte hard drive. So this is just in pass-through mode, so it's a physical hard drive, not a VMDK or VHD. So this is the NVMe RAID drive, so it's 4 NVMe drives of 512 gig each, and that's on a RAID 0 array. And then the last part of the puzzle was so using this nodes tab here, just spinning up various devices, and then allocating more CPU to them, more RAM, until it wasn't maxing out basically, and then kind of clarifying that by going onto the device and making sure that it was a bit more responsive. And since then it's been a lot better, so hopefully that will make the labs run a bit smoother now. Also what I've done is I've added a few more links into the management clouds, so I think basically, I thought that was started, we'll just start that up. So the way I'm going to do it is I'm generally going to work from the Network Management Center. Whenever I want to do work on client 1, the web server, the AD, ICE or Firepower, we'll just use the Network Management Center, and we'll go via HTTPS into these, and then RDP into client 1, the AD, the web server. I think we could probably stick the external host in there as well. We'll join that up. Something else I noticed when I was having a poke around, something that we missed from the last video, is we configured the links from the DC core into the main core, and we set up the port channel and the SVIs. We didn't actually set up these 3 ports connecting the Network Management Center to ICE and AD. Now these do actually work, so I have tested connectivity from the Network Management Center to ICE. prompting me for a password. I'll give it one. Okay, so I've been waiting for about half an hour to do this video, or make a start on the video, because this Windows machine was doing Windows updates, so it looks like it's just finishing that off. Yeah, so as I was saying, the connectivity between the Network Management Center, ICE and AD actually works because they're on the same subnet, but they are on the wrong subnet. So I could connect from the Network Management Center to ICE, but ICE wouldn't be able to connect to anything else on the network because it's in the wrong VLAN and wouldn't be able to reach its gateway. So we'll just go ahead and rectify that. So it was ports 1, 2 and 3, that's nice and easy. 1 is the AD, 2 is ICE and 3 is the Network Management Center. Okay, so a lot of this is going to be the same, so we'll run a little bit of a script for it. So interface gig 0/1 description, domain controller, switchboard mode access, help if I could type, access VLAN 17, port no negotiate, spanning tree EPDU guard, enable, and spanning tree port fast. Okay, we'll take a copy of that. Port 2 was ICE. And port 3 was our Network Management Center. Take a copy of that. We'll go into global config and we'll paste that in. Okay, we'll save our config. We will test to make sure that ICE is still reachable. Uh, 17.10, I think ICE is. Okay, yeah. 5 is the domain controller. Okay, great. Okay. Yeah, you'll see I've bookmarked the FMC and ICE just to make things a bit quicker. One thing that I also noticed, I've not decided whether I'm going to rectify this yet, is we have put the interface for ICE, the gigabit Ethernet 0 is going into the main sort of infrastructure, if you like. Now with ICE, you can only manage it over gig Ethernet 0. However, all interfaces can listen for radius and TACAX requests and all the rest of it. So what we could do is we could swap these interfaces over, which would allow us to manage it purely from the back end, and then have the gigabit Ethernet 1 interface going into the core switch, which would allow ICE to respond to radius and TACAX requests and all the rest of it. Not decided whether I'm going to do that yet, because the management through the switch actually doesn't seem too bad. Whereas previously when I've managed the FMC, for instance, through a switch in Eve, it has been quite poor. I think maybe ICE is a bit lighter on the application side. Okay, so for the rest of the video, we will be configuring the interfaces on the Firepower threat defense. So let's get cracking with that. Okay, we'll just get rid of that warning. Okay, so I think we'll start off with the inside interfaces. Do the DMC next, and then finally the outside. So inside 0/1, and also worth remembering that we have a trunk interface on here, so we'll need a sub interface. Yep, so we got a routed interface from the core switch, and then we have a layer 2 interface also being passed through the core switch, which needs to terminate on the Firepower as well. Okay, so we'll go to devices, device management. Okay, and I think I mentioned this in my last video, but you'll notice that since we put them in a high availability pair, there is no edit option under each of the single firewalls. We edit them as a pair now. Okay, yep, so there's a stateful and a high availability links that we set up previously. So we want to go into interfaces. Okay, so it seems that we haven't resolved exactly all of the issues. We're not we're not overwhelming any of our VMs. Yeah, we're not overwhelming the host. We're running at 50%. The memory looks high. That's because we have thick provisioned the memory for the VM. I know quite a lot of memory, so 6% is still like 5 or 6 gig remaining. So this could just be down to firepower itself. It is quite sluggish even at the best of times. Okay, so inside interface is gig01. So we'll edit that. And this is typical. I've been testing this all day. It's been absolutely fine. Okay, so name. This will be the inside interface. We will enable it. It's not management only. We will put it into, we will create the security zones as we go. We will stick this into the inside zone. And we will use the zone mappings when we go forward for the ACLs and stuff like that. This gives us a bit more flexibility going forward. So for instance, with the production network down here, you know, this is carrying a layer 2 VLAN up to the firewall, and we'll configure a sub interface in VLAN 65. Now there's only one network there at the time, but if we now configure it in a zone and call that production, later on if we were to add another production network, then we can just add that network to the production zone, and we don't have to completely go and reconfigure everything. Okay, so the zone will be called inside as well. Okay, for the IP address we want 10.11.0.2. We configured 1 on the core. We have a /29 subnet mask. And it takes either a subnet mask or CIDR notation. Okay, also we're going to configure a static MAC address here. So I just want to talk about this for a second because this is an issue that I've come across before. So what this can lead to, if you leave the firepowers, and this happens with other firewalls as well, if you leave them to have, if you don't configure a static MAC address, what happens is that it will take the MAC address from the interface. So this is probably more relevant if we look upstream, so towards these two routers here. So if you don't configure it, it will take the MAC address of gig00 for FTD1, and for FTD2 it will take the MAC address for gig00. Now we have configured these in HA, and we have set a IP address to be shared between the two. So what happens when you fail these devices over, when you go in there and you tell it to fail over, what happens is that, let's say FTD1 is the primary and FTD2 is the secondary. FTD1 is using the shared IP address, let's say 11.11.11.1 in this instance. We haven't set it up yet, but we'll say it's .1. And it'll be using the MAC address from gig00. Now when you tell it manually to fail over, what happens is FTD1 tells FTD2 that it's using 11.11.11.1 as its IP, and also tells it that it's using this MAC address from gig00. So FTD2 will carry on using that, and these upstream devices in their ARP table, so the ARP is the relationship between the MAC address and the IP address, they're none the wiser. They're still seeing 11.11.11.1 coming from whichever MAC address was configured on gig00. It's just now coming from here, but these don't care. They look at their ARP table, they see the same MAC to IP relationship, and everything carries on. However, what I've seen is that when you have a device go faulty or the power gets pulled to this, the failover isn't gracious. So what happens is this just loses communications, and that conversation between FTD1 and FTD2 where it says this is the IP address I'm using, this is the MAC address I'm using, doesn't happen. So now what happens is that FTD2 takes over the 11.11.11.1 IP address because it's in the config, it knows to do it, but then starts to use the MAC address from gig00, its own interface. So these upstream routers then, they're expecting 11.11.11.1 to come from a MAC address of gig00, and now 11.11.11.1 is turning up with a MAC address of this gig00. So its ARP table is now poisoned. So there are a few ways around this. So one of them is to configure a static IP. The other is gratuitous ARP. So gratuity is something that isn't asked for. So if the FTD supports it, it will just tell the routers. It will say, okay, update your ARP table, this MAC address for this IP address. Now I experienced this on the ASA. The ASA, I think, did do gratuitous ARP, but the devices downstream didn't reply to it, or couldn't understand it. So the ARP table never got updated, and we experienced an outage. So since then, I've always statically configured a MAC address to stop that situation. Yeah, so we'll stick a static MAC in for the active. So now in that situation, even if the power got pulled from FTD1, FTD2 takes over and says, okay, I'm supposed to be using this MAC address, which is in the configuration. I'm also supposed to be using this, IP address, and I'm also supposed to be using this MAC address. Okay, so that's the inside interface done. Now we want to configure another inside sub interface. So we'll go under the add interfaces, we'll say subinterface. So this is for the production network, which is up here and is layer 2 through the access switch, still layer 2 through the core, and its gateway will sit on the firewalls. So this is very akin to router on a stick. We will call it production. Enabled, yes. Security zone, we'll create a new security zone for this. We will call the zone production. We will tell it to be a subinterface of the parent interface gig 0/1. We don't have security group tags set up, so we'll untick that. We will give it a subinterface ID of 65, which is our VLAN ID. Now these numbers don't have to match, but why wouldn't you make them the same? Okay, and the gateway address is 10.11.65.1/24. We'll also configure a static MAC for here as well. Okay, that's good. We will configure the DMZ interface, which is, yep, gig 0/2. We will call this DMZ. We will enable it. We will set a new security zone of DMZ. Okay, we will give it its IP of 10.11.33.0. Dot 1, sorry, slash 24. We'll go into the advanced, and even though there's no layer 3 device upstream of this, we will configure the active MAC address. Next up will be the outside, which is on gig 00. So what I was going to do actually in the DMZ zone, but I won't. Usually what you would have in your DMZ is at least you would have one network for your production traffic, if you like, so the VLAN that this web server would sit on. But this would generally be a trunk interface, and you would at least have a management network, which 9 times out of 10 would be a link that was going to your probably ESI or ESXi Hyper-V host, just so you keep the management and the production traffic separate. However, we're using the management link on the back end, so we won't configure that because it's not getting used, and we've already done the same sort of setup on the inside. Okay, so we'll hop on over to the outside interface. Okay, it's really kind of baffling me why it's quite slow. As I said, I've been testing this all day. It's been perfectly fine. I think it's still a bit quicker than it was before, but it certainly has been pausing like this earlier on. Okay, so we'll give the outside interface the name of outside. We'll enable it. Yep, we'll set a new security zone, and we'll also call this outside. Yep, we'll give it the interface IP of 11.11.11.1/29, and we'll configure the static MAC address. Okay, and there we have it. That's our interfaces configured. We'll save our config. While that's doing that, we'll just double check our work. So 11.11.11.1/29 on the outside. Correct. 10.11.0.2/29 on the inside is correct. 10.11.65.1 for the production network, that's right. And 10.11.33.1/24 for the DMZ, which is correct. Okay, so we'll hit deploy. So for anyone that's not familiar with controller-based setups, we haven't actually configured these on the firewall yet. We've configured them in the management center. We now need to push the changes down to the firewalls. It's quite handy with firepower. It will tell you whether you will basically cause a interruption to traffic. So we'll select the device we want to push it to and we'll say deploy. Okay, and while that's doing that, we'll talk through the next part. I'll probably do a separate video on this, but I was hoping to get done today some access control lists. So these would be either very open or very closed, depending on the traffic flow. So for inside to outside, just initially we'd just put IP any allow. Let's say from production to inside, we would stick on a deny IP any to begin with, because there would be little, if any, traffic allowed. Whereas inside to outside, that's going to be mainly allow, maybe with some blocks. So that's the way in which we'll configure them to begin with. Just either allow all or deny all, and then as we build the lab up, we'll go and lock them rules down. I was also going to configure NAT on the firewalls as well as part of this video, but I think I'll do the ACLs and NAT in a separate video. Okay, so I'll pause the video here. We'll wait just to make sure that deploys properly, and then we'll go ahead and end the video after that. Okay, so that didn't take too long, and that looks like it's successfully deployed. Just thinking, so what we can do is we can jump on to, are any of the switches configured yet? Yeah, so we could jump on the call switch. And this should be all labeled up for us as well. Okay, so gig 0 and gig 01. In fact, yeah, 10.11.0.2 it should be. It's probably not going to respond because it's a firewall, but it should show up in the ARP table once we try to ping it. Okay. Okay. Ah, okay. Let's have a look. Yes. So let's take a look at that interface configuration again. We have 0, 0 and 0. 0, 1. So basically what we're doing here is we are tagging both of these VLANs. Oh, well, we are, yes, by default tagging. We want to tag 65, but we don't want to tag 301. We want 301 to be native. We didn't set that up as a sub interface on the firewall. So what we do is we go into interfaces, gig 0/0 and 0/1, and we say switchboard trunk native VLAN 301, and that says basically allow 65 and 301 over the trunk, but do not tag 301. Let that be untagged. Let's check that that's taken. Yep, okay. We'll give 10.11.0.2 a ping again. Okay, and it has responded, which I didn't expect it to. And you can see there, that is the static MAC address that we set up. So what we could do is we could do a bit of a failover test as well. So let's kick FTD1 over. So as I said before, this is where I have come across this issue, but hopefully we won't see it. So I'll tell you what we'll do. We'll get a constant ping running. Let's see how quickly it fails over as well. Stick a load of zeros on to make sure it doesn't fail for us. We will stop that. And we'll see how good the failover is, and we'll see if it carries on responding to that MAC address also. And that's not going very well. There we go. Okay. So let's have a look. How many pings did we lose there? 1, 2, 3, 4, 5, 6, 7, 8. 8 pings. Now these are supposed to be stateful firewalls, so that should not be the case. We should be failing over it instantly. However, this is a lab environment and we can't account for whether that's something to do with the lab, something to do with Eve in the back end, but still, 8 pings isn't bad. Okay, hopefully you've enjoyed this video. If you have, please like, share, subscribe, and thank you for watching.